Okay, so I will restart. Right? So I'm in the Faculty of Data and Decision Making, Decision Sciences, and my background is both in computer science and in psychology. I did bachelor's in both of them. At the time, I planned to work in the software industry. I was a leader of projects in the Army. And then I turned to the industry. I worked quite many years in the industry. And by then, which is quite a long time ago, I realized that the way we managed data at the time, there was no word like big data, no machine learning. And we managed data by using relational databases, SQL. And I worked for a company with a stream of logs every millisecond, another record, and it didn't work well with these SQL-based databases. So I decided I realized that I have a degree in psychology, and in particular in cognitive psychology, and thought about the human memory as a potential inference or insight into how to manage large amounts of data. And since then, I hoped back then to have a master's degree, understanding how the memory system works, how the index system of the memory works, and the plan was to go back to the industry. However, yes, then I realized that we don't really know how these processes work in humans. And the rest is history. I was transferred almost against my wish to a PhD program. And then I did a brief postdoc and was accepted to the Technion. It was the industrial engineering at the time. And I'm very happy to have the opportunity to work in such interdisciplinary environment. And you will see the outcome, how wide and how exciting can this interdisciplinary work can be. So today I will focus about and tell you about a very recent line of research. The two first papers were published with these colleagues, Eyal Berkovich from Rambam, sorry, yeah. From here, okay, and Matthew Helm from Penn State. Matthew is a dermatologist and Eyal is a radiologist. And the connection with Eyal was made by Moti Freiman. And he is actually my connection to this entire line of research. And of course, I thank him greatly. It was amazing, the connection that he made in his mind with Eyal. And he said, you two must get to know each other. And we have a rich, very, very wide, rich line of research. So I'm a cognitive psychologist. Okay, great. I didn't know that. Okay, so I'm a cognitive psychologist, and my basic research, my established esteem in the cognitive psychology comes from such tasks, riddles. I typically study riddles. So how people cope with challenging thinking challenges. And along the years, we claimed that these riddles represent how people think in real life, in professional challenges, in learning challenges, etc. And actually, I see in this medical line of research a fulfillment, which demonstrates how important is the basic science in order to inform professional related science. The meta-reasoning framework is a framework I originated here in the Technion. It takes principles of metacognitive. Cognitive is thinking, metacognitive are those processes by which we assess our confidence before, during, and after every thinking challenge. So here, for example, participants have to solve the riddle. Here, it's analogies. Those who did the SAT of Israel, it's analogies like in the SAT test. But immediately after every answer, they have to mark here on the scale how confident they are on the answer they provided. That's it.
Not actually, it doesn't matter if they're answered correctly, it's how much they're confident in.
I do document the accuracy, but for my analysis, the accuracy is secondary. Okay. Yes. And I measure response time. Response time is a very, very informative tool for my models, the models I do. In some of the studies, I also include the option to choose between submitting the answer or responding by I don't know. And in these cases, they have points that they can lose if they submit a wrong answer, and they can bypass this. In case they are not so confident, they can say, I don't know, instead of submitting their answer. So, in general, the reasoning cycle starts with identifying what is the requirement in the situation, what is the goal of the thinking challenge in front of me. Then we start looking into the problem. Sometimes we have an initial solution that comes to mind quickly. In this case, we might be very happy with this initial response that we produced and provided. Otherwise, we might get into rethinking and thinking thoroughly and reframing, etc. And this is the reconsidering. It doesn't happen all the time, but it might happen. And this reconsidering might take us long and long time. We might circle in this reconsidering more than once. And only then we provide the best solution that we could come up with. The meta-reasoning is this framework that together with my Canadian collaborator, we put forward in 2017, so it's quite new. The idea is that each and every switch between the stages is connected by a metacognitive judgment. When we get to see the requirements, we immediately ask ourselves, is it solvable? If it's not solvable, there is no point in starting to invest effort. Regarding the initial solution that comes to mind, we have the feeling of rightness. If it's high, we provide the solution. If it's low, it might trigger this more thorough thinking. The next step is regarding this thorough thinking. We have an intermediate outcome. We judge how well it is, what is the chance of it to be successful. We might rotate here more than once, and then we have final confidence in whatever solution we can. And in the example I gave you with the analogies, we see only this final confidence, and this is also what will be relevant for the medical line of research I will show you today, although we study all kinds of judgment. So we collect, for every task, we collect success rate, response time, between the presentation of the riddle and the solution choice, and the final confidence. And then we associate them. And these associations are very informative in order to understand the process.
Another question?
Yes.
Differentiate between female and male?
Typically not. Overall, males use higher side of the scale, so it seems that they are more confident, but overall, it doesn't interact with the things I examine, so they use another part of the scale, but it's less of importance for me. Okay, this is a classic finding that associates the three. We see here response time in the x-axis. We see success rate in the green line. We see that easy problems, we respond to them quickly and with high success. Harder problems take us longer and our success is lower. Confidence is typically overall in line with the trend of the success, but we see also very typical that overconfidence is very minor in the easy cases and gets larger in the more challenging cases that take longer. This is important, this figure, because I call attention to this part of the figure, that those problems which take most of our time have the least chance to be solved correctly and suffer from the most overconfidence, the largest illusion of knowing. I ask people, as I show you on the scale, how confident are you? You see how predictable is the pattern. No, it's not, but you see how predictable. This is a classic finding. I will show you this figure again and again several times today. Okay? If I want to challenge them with the option to say I don't know, I showed you. I allow them to submit or to say I don't know. The classic finding in this case is a very minimal cut down of the time wastage, and overall people are very much reluctant to say I don't know. They submit even answers in which their confidence is very low. Mm-hmm. This particular figure was done in Israel, but I will show you it's totally replicable, universal. So the research question of this medical line of research is, what can we learn from a comprehensive metacognitive analysis in case of high stakes reasoning, rather than just riddle? So this line of research includes 2 published papers I will show you here. I will show you also a glimpse of findings we didn't publish yet, and it's 2 lines or start of research, one with a dedicated AI system and with LLMs. Questions so far? Okay. Dermatology. When we talk about the medical diagnosis challenge and look at it from a cognitive psychologist perspective, everything looks very, very similar. A person comes into the clinic and presents a riddle. I have to solve the riddle and find the correct solution. I have confidence that guides my decisions, and I don't know, although not directly, a medical doctor will not say, go out of the office, I don't know, but we can bypass this and allow them to opt out in other ways. And I will show you how. So we have the same measures, and in this case, we used dermatology images taken from Penn State repository. And my colleague, Matthew Helm, knew the results of the biopsy of those cases. So he knew exactly what was the correct diagnosis. So there is a correct solution that the medical doctors must find. He then constructed 3 options, and I asked him to construct them to be challenging. Viable options But it will, if one looks very, very careful into the image, they should be able to diagnose and differentiate between the three options. Of course, I know nothing about these options. One of them is always correct, and two are always not correct. And confidence, as I'm used to collect. And instead of I don't know, we had here 4 options. Do nothing. In dermatology, they might treat in the clinic, unlike in many other professions. But in dermatology, they can actually do something in the clinic. So these are the submit options as far as I'm concerned. And the I don't know options are ancillary test and consultation. So ancillary test can be a biopsy, and consultation could be direction to a more specific expert. We split the data by the level of training of the participants. We had those in training, residents, and practiced dermatologists. I remind you that these are the results from readers, just analogies, as I showed you at the beginning. This is the image of the experts in dermatology. So you can see how similar are the patterns. You see, as with just readers, that quick responses have relatively high success, low overconfidence, and this pattern of these challenging cases in which the success is low, time is longest, and largest overconfidence replicates just perfectly. These are the residents, and these are those students, advanced students that are focused already in dermatology. We see that the practiced were best when they responded quickly. The residents cut the time. These took more than 20% for the lengthiest cases. These took 20 seconds. And these took 20 seconds. They overall were fast, showed minimal overconfidence, and even they were better in the most challenging cases. Interesting. And those in training showed still the pattern, but they were more overconfident, lower success, and overconfidence was throughout the time investment. Yes, yes. Well,
no need to specialization for it.
Absolutely. You can look. This is published already. Journal of American Academy of Dermatology International. Those in training were worst in everything. Okay.
We should go to residents.
Sorry?
If we have a problem, we should go to residents. That's what I'm saying.
We have there a finding, I will show you immediately, that may doubt this conclusion. Okay. This is a case, one of the 10 cases of melanoma that we had among the 50 cases overall. And let's see the results for this kind of all the melanoma cases together. The practice participants were less than 50% correct. Overconfidence was intermediate. Residents, 35% success. Confidence is higher. Do you note? To those in training, 20% success and as confident as the others. These are response times. Residents were the quickest, but the success was lower in those cases.
In this case, the confidence that it's meaning that they don't ask consultation.
I will show you the results immediately of those decisions. This is, oh my God. My colleague was shocked by looking at these results. And I appreciate him of the willingness to publish this result. This is, the participants are his colleagues. 12% of the melanoma cases were totally missed in the sense of saying, do nothing. Not sent to another exam, but do nothing.
So
yes.
All of that were through pictures, right? No, for example, the dermatology today is also treated through videos, but still.
Videos and stills. This is like the remote e-dermatology service.
Many times, even for easy cases, the doctor actually asks the patients to come in as a follow-up.
Here they said do nothing, not auxiliary tests.
So
no.
They have the option to say, because I don't remember I saw that, to come in, I want to see it in person.
It was either go to an expert or do ancillary tests. This could be.
I wonder how much the picture actually is quality that.
My colleague was asked to make sure that people can discriminate if they look carefully enough.
The reason I'm asking that because many times those modalities are not those trainings or even the specialists are not trained based on pictures like that.
So they do. He said it's part of the stream of work.
They had the option to send them to another test or another constellation.
Yes, but they chose do nothing. Okay? He was shocked. These are the decisions, and we see here the I don't know options in blue and in yellow. The ancillary tests and consultations are here, and we see that the practiced participants use them the most, not the least. And those in training use them the least.
That's the Dunning-Kruger effect.
Yeah, yes, in a sense, yes. So would you go to a residence? Not necessarily. Okay, there are.
I want to go to any doctor.
Yes. But we show also the correlation with the confidence, and the practiced are most tightly in line with their own confidence. And those less and less. Yes. Sorry?
In the second sentence, there is no statistical significance between practice and residence.
In most measures, but in this one, yes. Okay. Okay. This is the results not included in the paper. This is to demonstrate a metacognitive analysis. What are the benefits beyond pointing to this waste of time and overconfidence? What else can we do with practical implications? So here, these three options, my colleague chose in some of the cases, no any malignant option, while in other cases, he chose to have one malignant option or two. And I suspected, based on metacognitive theory, that this might be a misleading factor. Let's see the results. So we see here a figure of success and confidence with no malignant options, one or two. With no malignant options, we see success is 60%. It's the mean in this sample of stimuli, and a minor or modest overconfidence. With the malignant options, with one, the overconfidence was smaller, but if two, they have 50% success rate. which means they chose one of the malignant options, but not necessarily the one that was the relevant one. And confidence was higher, which opens a huge overconfidence. And this is very problematic in terms of the next steps of decisions that they take.
But can I get bias of people to identify or recognize specifically bad things in, I don't know, in every situation in life, right? No?
Yes, but these are dermatologists. This is their main job. To find.
Why did they specifically choose the malignant options rather than the benign?
I guess that the skin texture looks like something malignant, but they didn't know which of them to the extent of random choice.
Maybe they're just being careful, right? Like it's safe.
Careful with this confidence, higher than all other cases.
I mean, just in the sense that, oh, it's better to say that it's something wrong that we should investigate further than to just say, no, you're right, go home.
In that case, we should see here more additional tests.
Oh, yeah. So they just got it wrong and didn't ask for more tests.
In some of the cases, it's
Confidence is meaning that they choose not to treat or to treat.
not necessarily. Depends on how tight confidence predicts the decision. Yes, yes. You have. It doesn't directly say. They can rate their confidence high and still ask for ancillary tests. It's not very tight. It's like 0.6 correlation, something like.
Misleading the presentation, because if somebody feels that there is a malignancy and he is asking for more tests, and he is sure
I have the correlations reported.
you will consider that there is incontinence.
Yes, but it's average across the people, and there are 70 people. It's average across them and across all cases, right? So we have to look at the correlation between confidence and the decision how to act. And these are moderate, like 0.6.
So what do you want to imply from this?
That we can, with cognitive knowledge, we can identify the cases which are prone to error and to illusion of knowing. And this is what I told you earlier. I would focus AI systems on these cases that are particularly misleading. This is the practical implication.
Misleading or not misleading is based on what are the options. If the option is...
But these are options that my colleagues thought are relevant to consider.
If you add more severe cases for cancer, more cancer, then you have to be more cautious from the beginning. So it's not...
Their main job is to identify cancer. This is how they see themselves. It's not those itches of the skin, but identify cancer.
But if we have to play with sensitivities specifically,
Yes.
it depends on the severity of the choices we have to do.
Yes, but these options, my colleagues thought that they are relevant. It's not just arbitrary options, right? Okay, let's continue, please. Okay. We see that confidence got up and success got down. These are the cases I aim to identify as a metacognitive expert. Okay. How do we stand? How much time do we have? Okay. Radiology. This work was done with Eyal Berkovich. That it's not in press. It's actually published in Radiology already. Here Eyal is an expert in bone lesions, and we had a collection of bone lesion cases from Rambam. And the question was very, very specific. Is there a bone lesion? Yes or no? That's it. And how confident are you? Again, for me, as a metacognitive researcher, it's all the same. We have success, we have confidence, we have response time, and the associations between them. In this case, also, we allowed them to consult a senior or to ask for additional imaging tests, which means mainly MRI, could be CT by the case.
And here there are no options like do not.
There is no do nothing here. It submit no, it means do nothing.
Okay.
And there is no treat. Radiologists do not treat. This is the main difference.
Oh, so they just look at it and they say there's something or not, and the consultation.
Yes.
No, if your answer is yes, it's good with the resolution.
It can be submit, then it means you have a lesion and that's
I'm
it.
confident you have.
Yes. And there is the other options. Okay. So as far as I'm concerned, as a cognitive psychologist, these are very similar screens and requirements to those of the dermatology. However, after looking at the data, I told Eyal something looks not in place here. And he said, of course, when there is a yes response, we must consult or do additional tests. We do not diagnose cancer based on a single image. When we say no, we have the responsibility, very severe responsibility, that there is nothing here and nothing will be done. So the responsibility in case of no is very, very high, might be higher than with the yes response. Okay. The result, this, I hope I don't bore you. You saw this image already before, and I told you that it's very, very generalizable. We see again that response time, when it's quick, success is high. Here there is no overconfidence, which is rare. And when people invested most of the time, their overconfidence is very much pronounced.
Which in the case their own neighbor physician has except for the
Just zoom in.
doesn't know the age, doesn't know
No background, no background.
usually the information that
Yes,
the basic information that
Yes.
every clinician has.
yes,
Not
that's
to
correct.
mention other modalities.
That's correct. This
This is
for
a very
the
harsh test.
yes, it was planned to be. And the cases were challenging. You see, very, very few easy cases, and most of them were challenging. Yes, and we told them that it doesn't represent, the collection of images doesn't
It's not a
represent.
routine assessment.
No.
that
No,
Radiologists will do on a daily basis. That's why.
no. Yes, that's correct. The participants were 28 radiologists from Israel and 50 people from around the world that we identify to be medical professionals, could be radiologists or other professions that know to read X-rays. It can be in orthopedics, it can be physiotherapists, it can be family doctors who read X-rays on their jobs, but they are not radiologists. I will show you the results. Okay. These are the classic findings. When splitting the data by the yes and no responses, we see a substantial difference. The yes responses look similar, just with smaller overconfidence. The no responses very, very generally look similar, but the overconfidence is huge, and there is hardly any slope and any sensitivity of the confidence ratings to the passing time and the doubts that should have been raised. So the distinction between the answering formats of answer options of specific diagnosis versus the yes-no pattern of answering makes a difference. I didn't predict it in advance.
Some of the yes approach.
Depends on the response times. It's per response time. Per 5 seconds response, 90% were correct. No, 100%. They were sometimes wrong, even in 5-second responses.
Sometimes I see that the same, say, 5 seconds, there is 80%, no, 70%.
Out of the yes responses, there is a percentage of correct yes, or it's not necessarily correct yes. Okay, benefits of the metacognitive analysis here. Here I realized that based on my research with readers, that there might be a difference between cases with few bones, like a knee, or many bones, like the lung structure, chest structure. And we see that when we look at the yes responses, there is different trend for the few and many options, but it's not so severe, the metacognitive bias. So this interaction is significant, but let's leave it alone because we have much more substantial issues here. When they say no, this pattern just goes a little bit lower, lower success, lower confidence. As long as their overconfidence is similar, I'm satisfied. But in case of many bones, like the chest case, this is the success rate. It would better not to look at the image at all and just say yes or no randomly. Oh my God effect. And confidence doesn't distinguish between these cases whatsoever. This is something that AI systems should address, for example, as for if we talk about practical. If we have to draw implications for focusing AI system, I would give AI system many, many cases of many bones, more than cases of a few bones. And this is the result of metacognitive analysis that we could not know otherwise. And confidence here is totally blind to the changes in success rate. 5 more minutes, you said? Wow. Okay. These are not published yet. I will go through them very quickly. The first one, we had also a collection of lung X-rays. In this case, in this experiment, we had the lung case. Yes or no, there is a lung infiltration, confidence. And then we forced everybody to get an advice from an expert. Here, the expert was human. And another group got the same recommendations, just framed to be from an AI system.
So in any case, they got the same recommendation?
Same recommendation.
The only difference is whether they think it was a human or
yes. We calibrated the trust. We chose the recommendations based on an expert outcome, and this expert was 85% correct. We were disappointed. There were little differences between the two. The only difference we allocated so far, we are still analyzing the data, was that with the AI, they asked more for consultation of an expert. And this is very expensive for the health system. So this is has very heavy implications. People want people in the loop. They would not submit an outcome of an AI as easily as they would if a person would provide this very same recommendation. Why it's striking? It depends. The implication for the health system is heavy. This is second opinion is the most expensive resource. Okay, and it means that although we calibrated the trust explicitly, they trust the AI less. Okay, the next one is also something we still analyze. We challenge LLMs. ChatGPT, the top version of ChatGPT with this very same task. Please see a set of images, tell us yes or no, is there lung infiltration, and tell us how confident you are. And we examined several prompts. We designed them based on, my colleague here is a data scientist from Bar-Ilan University, Elad Yom Tov, and we designed the prompts from both insights. Actually, 3 insights. It's also Eyal Berkovich. Each one of us raised important aspects to include in the prompts. And the question was, can we pair LLM results and human results to get better outcomes? So we have solo humans, as before, solo LLMs, in which we manipulated expertise level. Please imagine you are a lung expert or a required detailed output. Please explain your decision. This did not make a difference. Surprisingly enough, for me it's surprising. The prompt detail level, though, whether the prompt detail more, although the image is the image and the infiltration is the infiltration, prompt should not take effect in this case. It's a bias. There is nothing really substantial to say beyond diagnose this lung infiltration. And in this case, the low detail level produced lower success, as low as the medium detail level, and the high detail level was substantially better in actual success in diagnosis. Confidence was a little bit lower, and there was no overconfidence. This is crazy. It's the least important part, the detail level of the prompt itself, and it makes such a substantial difference. And then now we are in the process of pairing. We already know these results. If we look at radiologists alone and non-radiologists alone, non-radiologists are a little bit worse in success rate. LLMs are similar to expert radiologists alone. When we pair them, we get similar results in terms of success. The best one is the radiologist plus the best prompt we had. Importantly, the prompt is what we ask the LLM to do at the highest detail level, because those produce the best outcomes out of the LLMs. Okay, the best prompt we could produce. We see that this prompt produces outcome by the LLM and the non-radiologist as good as radiologist alone. And this is important. Okay? The LLM can bring the non-radiologist to the level of radiologist. This is the first finding. As for confidence, radiologists and non-radiologists were overconfident, while the models were less. Here, the model is well calibrated, very nicely calibrated, and the pairing of the humans and the models are also well calibrated. So this outcome of both of them is better than humans alone, but LLM alone doesn't provide the solution. The solution is the best advancement is taking non-radiologists and adding an LLM. This is the best outcome. And now we analyze those biases, like the many bones that we showed before. Now we have some ideas with the lungs also. And for the bones, we do the same process for the bones too. And I would like to highlight biases of the LLMs that differ from the biases of humans and show how we can overcome the biases. This is the aim. We are still analyzing the data. Okay, to summarize. We saw several metacognitive pitfalls, overconfidence, predictable biasing cases, inefficient use of time, misalignment of decisions to confidence. All these are metacognitive pitfalls. First, we see that medical doctors are human too. The biases are similar to just readers. Yes. I hope that somebody will develop, following these studies, calibration training for medical doctors, decision strategy training, how to take the decisions effectively, and AI integration should take these biases into account, assuming that it doesn't seem that AI will replace people, but will complement them. And we need to aim for the best human AI collaboration. Thank you, Ben.